All right, thank you guys. Today we are going to continue our series on integrated testing into our development flow with our discussion on hands-on with TestNG. So today we're going to briefly talk about what is TestNG and some of the different components about it and how it differs from unit testing. And then we're just going to jump out of the slides and get right into the nitty-gritty and actually get our hands dirty and walk through setting up kind of a working environment so we can actually use TestNG and write unit tests and test some sample code that we'll throw out there. We'll get through probably half of the discussion of TestNG. We'll get through most of kind of getting your hands dirty where you can actually start getting in playing with TestNG. And then next time we'll come back and we'll focus on the more advanced features with the listeners and reporting. So what exactly is TestNG? You can find TestNG at testng.org/doc. And it's got a pretty good overview on getting started here. And then you've got a couple different tabs here. So you can migrate from JUnit, Java Docs. They have a nice long documentation on here, which is pretty much a full book of all the information you can possibly find on TestNG. And to sum up what how the documentation describes TestNG, it describes it in a couple different ways. So TestNG is a testing framework inspired from JUnit and NUnit, but it also introduces some new functionalities that make it more powerful and easy to use. TestNG is also an open source automated test framework where NG means next generation testing. TestNG is similar to JUnit, especially JUnit 4, but it is not a JUnit extension. It is inspired by JUnit. It is designed, however, to be better than JUnit, especially when testing integrated classes. Creator of TestNG is Cedric Fust. He's still a part of the application and the continued development of TestNG, but there are some other contributors that have jumped in and started helping out. It is an open source platform, so you can go out into GitHub and mess around with the actual source code and add some additional features to it if you'd like. It also eliminates most of the limitations of the older framework. TestNG gives the developer the ability to write more flexible and powerful tests, as it heavily borrows from the Java annotations that were included with JDK 5 to help define its tests. It can also show you how to use this new feature of the Java language in a real production environment, which we'll get into that later because it is very heavily annotation based, especially if you want to keep it very robust and scalable for your testing. TestNG is also designed to cover all categories of tests, not just unit tests. It also covers functional testing, end-to-end, integration, and the list goes on. Some additional new features that make it more powerful and easier to use versus JUnit are its embracement of annotations. You can run your tests in arbitrarily baked thread pools with various policies, whereas JUnit, you kind of had to run each test one at a time. You can also test to see if your code is multi-thread safe. This is a nice feature which comes from the ability to be able to run big multi-threaded pools. It also gives you the flexibility to create your own test configuration files. It also supports data-driven testing with a annotation of data provider. It supports for parameters. So you can pass in parameters actually in your XML, in your JSON, in your JSON, in your spreadsheet. But you can pass all these in and make it a single test suite per se. It could actually handle multiple different test cases on the data. So it kind of gives you the ability to kind of make that hybrid testing environment where you're not just doing individual test cases, but you can also have the data drive the test cases. It also allows for powerful execution model. So no more test suite, so to speak. You can actually create multiple test suites or groups of test suites. It's supported by a variety of tools and plugins: Eclipse, IDE, Maven, Ant, Ivy. It embeds Bean Shell for further flexibility. It can use the default JDK functions for runtime and logging, no dependencies. Dependent methods for application server testing. TestNG uses more Java and object-oriented features than JUnit. It supports testing integration classes. By default, no need to create a new test class instance for every test method. And we'll see an example of that today. It also separates compile time test code from runtime configuration and data information. It also introduces test groups. So you can compile your test and just ask TestNG to tell which test to actually run, be it front end, be it back end, slow, database, without actually creating different test cases. You just define all your test cases, you can set up your test suite, and with just a tweak to the configuration, you can run a different set of tests. Also supports dependent test methods, parallel testing, load testing, and parallel failure. So that just kind of gives you a listing of some of the nice features. Now, the reason I personally like using TestNG over JUnit is because of some of the shortfalls that come with JUnit. For instance, JUnit was initially designed to enable unit testing only. Now, it's since kind of grown from that. However, the framework itself has not really grown to go beyond the typical unit testing type mentality. JUnit cannot do dependency testing. JUnit has poor configuration controls. Your setup and teardown require you to actually create static methods in order to pass information between tests at the startup and teardown. JUnit is intrusive. It forces you to extend classes and name your methods a certain way. JUnit uses a static programming model, forces you to recompile unnecessarily. JUnit management of different suites of tests is complex and can get very tricky. So you have lots of properties files that kind of you have to manipulate and maintain, and it just gets ugly. So that's kind of the overview of TestNG. So now let's get our hands dirty. So the first thing you want to do is we want to get our environment set up. Now, typically, just like Java, you can do all this at the command line. You can do everything through Vim or Notepad, but we're going to focus primarily on the Eclipse side of things. But before I get to that, I will briefly give us a reminder of how to set our environment variables so that we can actually point our command environment to our actual utilities, our Java runtime, our TestNG runtime, so that we actually can run these from the command line if we so choose. And just to give you a quick refresher, so if you actually want to manipulate in Mac, and this command is actually fairly similar in both Windows and Linux, it's just where it's implemented is slightly different. So on Mac and Linux, you would run the export Java home and then include your Java home path. Whereas with Windows, you can open up the command console and type in the same command. However, with Windows, you actually want to go find the environment variables within the Windows configuration settings and actually set to the environment variables, actually add a new variable called Java_home, all caps, and then set the value to be the path to your home directory. You also, in Windows, need to set up your path, add this to the class path. So you would actually append to the path, you would actually add the Java home /bin. In Linux, you would also add export path. You would also include the path and also append to the path the Java home /bin. Mac, it's not required. You just need to actually do this command right here. And this is actually a neat little trick that I learned to add to my bash shell that will allow me to quickly jump back and forth between different versions of Java now. Since Java 8 was the last real version before Jigsaw, and Java 9 and 10 are Jigsaw compliant, 10 especially. So if I want to start messing around with Jigsaw and configuration files, I just jump back and forth. And all I have to do is type J8, J9, and J10 to jump back and forth between the versions. When we want to use TestNG, the other thing we would need to do is we need to download the TestNG file and go through the same setup as well. So you would actually do TestNG_home and actually put in the same information. So you put in the path information to where you have TestNG. To get the latest TestNG file, you can go out to the testng.org, go to download. And you have a couple of different ways you can get it. You can pull it from Maven. You can use Gradle. You can also pull the latest snapshot from the repository, so if you want to hard code it. The other place is you can use the Eclipse plugin. Just FYI right now, with the latest version of Eclipse, this guy is broken. If you actually try to pull it from the marketplace, and for some reason, this URL is not working. I found another one that does work, and I'll show you that here in just a minute. But let me also mention that just like the Java home, you also have to set the class path using testing home as well. So you need to add the testing home / the TestNG version jar, which typically is 6.10, I think is the latest. We'll verify that in just a minute. So I typically use a flavor of Eclipse called STS, which is from the Spring community. It comes preloaded with all the Spring jars preloaded, so you don't have to configure anything. For TestNG, though, we need to get the latest version of TestNG. So we go up here to Help, and you go to Install New Software. And the path to get the actual software, so here is the one that was on their website, the http://bus.com Eclipse. This guy currently does not work. For some reason, there is a problem with the Eclipse installer, but this version here has the latest release. So if you go to dl.bintray.com/teams/teams-p2-release. I will put this in the blog notes when I put this video out, but it's right here so you can see it. You expand out. I actually already have it installed. So let me uncheck that. There we go. So you would just install the TestNG features, or basically just click this guy and install everything. And then it would go through the install process. It'll ask you to restart STS. Once that's done, let's make sure it works. So let's create a new project. First things first, if the plugin installs correctly, you will see a new folder here called TestNG, and it lets you create a TestNG class. That's not the one we want to do, though. We're going to use Maven. I typically like Maven projects because it allows you to control your dependencies, your third-party jars, a lot easier than trying to load them all into your project on the fly and then try to keep up with the version maintenance and where they're stored in your project. Maven simplifies all that. Okay, we'll use default workspace location, create a simple project. We don't want to skip this part because I actually want it to include a few things. We're going to use the quick start architect. Now, I know you're not supposed to use underscores, but for simplicity to help make things a little easier to read, we're going to use the underscore here just so you can kind of see in the XML and in the configuration files what we're actually doing. So to quickly go through, so we've got our new Maven project. We actually have a simple application here that just spits out hello world. And we actually have a unit test. So this is a JUnit test. And if we run this guy, it ran our JUnit, gave us our nice little JUnit report here. It had one method it tested. So this one just asserts true. But if we actually ran the class, it would spit out hello world. So just a simple little project. First thing we want to do, though, is we want to add a few things to our project. So we could add TestNG one of two ways. We could right-click on the project, go down to Properties, Build Path, and we could actually add TestNG here. I don't recommend doing it this way because then you have to actually include TestNG in your jars, wars, ears, however you package this up and send it out. However, if you do it with Maven, it's included for you. So we will back out, go over to POM, and here's where our JUnit is, and this would be where we would put the TestNG information. And for that, we go back out here, and here's our dependency, TestNG, Maven. But this may be older information. So let's go out to Maven repository and see what the latest and greatest version is. TestNG. And if we come in here, we got version 7.0. And if you just click, it copies it to your clipboard and you paste it in here. Get rid of the unit test. There's our TestNG. It's installing TestNG. And now look, our JUnit test is now failing because we're not including JUnit. Now, I could still include JUnit. There's nothing wrong with having both of these. You just have to be clear when you actually define your class, which one you're actually going to use. So let's go create a simple TestNG class. Now we go to Other. Now we will take our TestNG class. Now this is nice because this allows us to do a couple different things. So it tells us our source path, tells us our package name, and then we can give it our class name. So this one, we're going to essentially test all the annotations. So we'll do annotations test. Basically, TestNG, the naming structure, you kind of want to postfix all your test files with test. So annotations test. Really, you could follow the old JUnit test where essentially every class name you have has a following class name test. But you can actually do other more complex testing as well. So you could have like database tests, XML data tests, and not necessarily have a correlating main class to go with it. All these annotations, we're just going to select all these for right now, and we'll come back and explain what these are in just a minute, but it'll just save us time. And then we also need to have, we can also create an XML suite file so that we can actually run test suite. XML, finish. So one thing we noticed right off the bat is it put our test suite XML file in our source path. We really don't want it there. So one of the things we also want to do to our project is add a test resource. So let's go to Other. Please. Under Source. With these guys, these sometimes get included when you do the Maven build. Okay, add a folder. Under Test, we can create one called Resources. Okay. So we now have a Resources folder. So we will take this guy and drag him up to Resources. So if we look in here, this is a pretty standard, very simple test suite file for TestNG. We'll come back to that in just a minute. Let's go back and focus on our class here. All right, so this is what a TestNG class looks like. So we've got some things in here where we've got test, we formatted after methods. So we have a bunch of annotations that are going to do something for us. Now, we don't have to actually define all the classes or all the properties files because of how TestNG is annotation based. When we actually run these tests, TestNG, the framework itself, will look for these annotations and then actually run your tests based on the annotations. So you don't have to do a whole lot of constructing or configuration. So let's take a step back and briefly talk about the basic annotations here. So the traditional way to indicate test methods in JUnit 3 was by prefixing the names with test. Right? This is a very effective method for targeting certain methods in a class as having a special meaning. But the naming convention doesn't scale very well. What if we want to add more tags for different frameworks? Or it can also be rather inflexible. You know, what if we want to pass additional parameters to the test framework? So annotations were formally added to the Java language in Java 5, like we mentioned before. And TestNG made the choice to use these annotations. So here's kind of the definition for each of these annotation types. So first we have before suite, and this annotation method will be run only once before all tests in the suites have run. After suite, just as its opposite, the annotated method will be run only once after all the tests in the suites have run. Before class and after class, the method will only run once before the method test is in the current class is invoked and after the class has been invoked. Before test and after test, the annotation method will be run before any test method belonging to the class inside of the test tag is run or after the test tag. Before groups and after group, this configuration method will run before. This method is guaranteed to run shortly before the first test method that belongs to any of these groups is invoked. And after groups will run after the last test method that belongs to any of these groups is invoked. Before and after method, these annotation methods will be run before each test method and after each test method. Data provider. So this one's neat and interesting. So it marks a method as supplying data for a test method. The annotated method must return an object, a two-dimensional array, where each object can be assigned the parameter list of the test method. The test method that wants to receive data from this data provider needs to use a data provider name equal to the name of this annotation. This also works with parameter files, parameter annotations, and parameter that can be passed in from the test XML file. We'll talk about that later. Factory marks the method as a factory that returns objects that will be used by the TestNG as test classes. The method must return an object. Now, we're not really going to talk about that one much today. Also, we've got listeners and parameters. The listeners define listeners on a test class, and parameters describe how to pass parameters to a test method. And then finally, the one that we will be looking at the most today is going to be the test annotation, which marks a class or a method as part of a test. Some of the benefits of using these annotations are TestNG identifies the methods it is interested in by looking up the annotations. Therefore, method names are not restricted to any pattern or format. We can pass annotation parameters to annotations. Annotations are strongly typed, so the compiler will flag any mistakes right away, and test classes no longer need to extend anything such as test case, which you had to do a lot for JUnit 3. So here we are. We have all these annotations. So how are these annotations actually going to work? So let me actually pull some code here that I've actually pre-added. Here we go. So I've added, essentially we have the same methods as before test, after test. But what I've added to this grouping is I've added some system outs that basically tell you which method is called. So now we can kick this guy off. Now, instead of it being JUnit, it's now TestNG. And the first thing you'll see is we have a different dashboard. So here was the JUnit, and JUnit was just number of runs, errors, and failures, and it gave you your failure trace over here. TestNG now gives you a full breakdown of all tests. You can also have a tab to just look at what fails, and you have a nice summary now that tells you what methods were excluded, what methods were run, how long it took to run them, etc. To me, this is a little more intuitive than just the typical JUnit. And also when you're running multi-threaded, which you can't in JUnit, this guy helps keep all of it clean and in check. All right, the other thing to look at is what wrote after the console. So the first thing we see is, okay, before suite ran like we thought it would. Then we have before test, before class, before method, then it ran test case 1, then it ran after method, and then before method again, we ran test case 2, after method, before method again. And this is interesting. We actually have 2 outputs for the test case 3. That's actually because we provided 2 data sets to the test case. And we'll take a look at that in just a second. So again, we have before method, after method, before method, after method, then after class, after test, and then finally after it reports that everything passed, it gave us our output for the actual run. It then runs the after sweep. So this is where we would want to run something that would tear down or clean up any database or any erroneous things we have out there that we would want to clean up. So let's look at this. So here is our data provider here. And our data provider actually has two objects. So we have two data points that we're passing in. So any test that receives a data provider annotation, and you pass in the actual data provider, it's going to run that test for as many data provider or data points that you pass into it. Same goes if you're actually passing in parameters from the test suite file. Now that we've run this, so let's discuss, so based on the output, the execution procedure is as follows. So first of all, before suite method is executed only once. Lastly, the after suite method executes only once. Even the methods before test, before class, and after test methods are executed once. The ones that are different, though, are the before and after methods. So these methods execute for each test, but before executing the test case and after executing the test case. And then in between before method and after method, each test case executes. So this is essentially a basic test case. The other thing we've added that I kind of snuck in here when I pasted the code is I've added things called groups. And I've defined the little groups in here, groups test 1, test 2, DP. This allows us to kind of include and exclude different test cases within our test. So the test cases in TestNG, you can set them up and define them in multiple different ways. So right now we're only looking at the actual test class or our test case, so to speak. If we go to our test suite file that was created, in here we have our suite definition, we have the test definition, and then we have this guy here, the annotation test. So if I actually run this guy instead of running our class directly, so let's talk about excluding tests. So the test cases are excluded using TestNG class. This class is the main entry point for running tests in the TestNG framework. Users can create their own TestNG objects and invoke it in many different ways, such as on an existing TestNG XML file, on a synthetic TestNG XML file created entirely from Java, or by directly setting the test classes themselves, which was running it directly, or as you saw here, as I ran from the XML. You can also run it from some additional parameters if you were to run this from the command line. But like I said, we're not going to get into that today. But just be aware that you have a couple parameters you can include at the command line. You can include -d, which specifies an output directory. So you do -d in your output directory where you want the results to go to. -test classes, you can then specify the specific class name that you want to run. -test jar, you can specify which jars to run that contain the test that you wish to kick off. There's also -source dir, so you can pass in a separated list of source directories using a colon. We got -target, -groups, -tests, run factory, and -listeners. But for today, we're just going to keep focusing on the TestNG test in Eclipse. So here we are looking at our test suite file. So this is the XML file for our suite test. So a test suite is a collection of test cases intended to test a behavior or set of behaviors of a software program. In TestNG, we cannot define a suite in testing source code, but it is represented by one XML file, as suites is the feature of execution. It also allows flexible configurations of tests to be run. A suite can contain one or more tests as defined by a suite tag. The suite tag is the root tag of your TestNG XML, describes a test suite which in turn is made up of several test sections. Now, what all that means is that you can define multiple test suites with multiple test XML files. You just have to rename them. You can actually group these test suites together in a test suite package, but we're not going to get into that one today. We'll save that one for when we talk about listener. But within our test suite, we can specify test cases, all the test cases or tests that we want to run. This is so powerful because when you actually start thinking about testing an application, now if you're going back to just an old standard simple website page you wanted to test with just simple forms, like a contact us page, sure, one test suite with a handful of test cases would probably meet your need. However, when you get into more complex applications where you may have multiple user roles and you may have to actually pass a result from one user session to another user session who actually has a different set of conditions that they need to test, but they need the results from the first test, you couldn't really do that with JUnit or in a lot of the unit testing frameworks that are out there. Because in their mindset, a unit test is a single unit of work. So you're only testing one thing. And really, you're only focused on that one thing. It really doesn't follow the concept where what I do in this test may work in something else. So you can create a test suite with a bunch of these test cases, but you can't create a test case that essentially is universal, that could be used in multiple test suites with a combination of other test cases. So we'll get into that a little bit more in the next lesson of this, but just keep that in mind that this really allows for scalability. You can really do a lot of things with this that you really couldn't do with JUnit. Some of the additional things within the test suite file that I would like to point out is the suite tag actually has some attributes. So right now we see right off the bat that was predefined for us, we have name, suite, and we have parallel false. So name is just the name of the suite. It's mandatory, and it's also used for reporting. So it takes out the command line, tells you what ran. It also tells you when it generates the reporting, which is something I haven't gotten to yet. But yes, every time you run a test suite, you actually get generated HTML reports for your test run. We'll look at that right before we end the lesson for today. But the naming is important. So the naming shows up on all the reports, and the name shows up in all of our outputs to the console. Parallel allows you to run your TestNG threads either in parallel, or you can run them side by side, or if you don't want to run them parallel, and then basically run them in order, run 1, 2, 3, 4, 5. You also have verbose. And verbose is fun because verbose is 1 to 10, 1 being the least amount of output that we want to generate. So we see the same output we had before. But if you go all the way up to 10, you can see a whole lot more information as to what's going on. So if we had just ran our test with verbose 10, it actually would have told us the same thing our system outs did. So see, annotation test dot before test suite was run before test, and again before class. So here's essentially what our system out provided us. So if I remove all the system.outs, rerun this, here is what the logs would kick out for us. Thread count. So if we wanted to run this multi-threaded, we would include thread count. Right now, I'll keep it 1. Since I have parallel false, then it won't run side by side. I'll go 1, 2, 3, 4. But typically, if you want to run multi-threaded, the parallel mode is enabled and it's ignored otherwise. So if you have parallel here, but you have thread count greater than 1, it's going to ignore this because this is telling it that you're going to run multi-threaded. There's also the annotations, which allows you to specify specific annotations you're using in your test. That's beyond the scope of today. And then the other one that we'll briefly look at is you can do timeout. And this is milliseconds. So if we wanted it to go a full minute, it would be 60,000 milliseconds. And we can rerun this guy. It ran once. Everything ran fine. Everything passed. All right, so now let's expand this. So let's take our annotations test and create a second one. Everything's the same, no big deal. And if we run it by itself, we should get the exact same output we had before, and we do. But now, let's add another test to our actual test suite. So all we have to do is add another test section. Now, if I just do this, say, okay, we got annotation test 1, annotation test 2, and try to run this, this will fail. And it will fail because you cannot have the same name. So here again, name is critical. Just like how we named our suite, the names of our tests also get sent to the reporting. So if we have duplicate names, we're going to run into problems. So let's do test 1 and test 2. We run, yes, save. And now if we look at our report, well, the console, we actually have test 1 and test 2. And if we go look at our output, there's test 1 and test 2. Now, you notice they're run in order. It gets a little tricky when you run multi-threaded because some of your output may overlap. Again, it may run so fast it didn't matter. So annotation test 1 and annotation test 2. So both tests were kicked off at the same time, as you can see here. But for reporting reasons, it didn't overlap within the actual test run themselves. Let's see, test 1 cleaned up, and then test 2 kicked off, test 2 cleaned up, and then both tests wrapped up at the end. Now, say we were working on a feature and it wasn't quite ready for us to test. Well, we could actually go in, let's see, we'll take this one here, test 1, and I can add an additional argument to the test annotation, and we can say enable. Oh, so sometimes it happens that our code is not ready, and our test case written to test the method code fails. Well, so if we wanted to just take the test case out of rotation, we can come in here and we can set the enable flag to false. So if we run our test case now, and in this case, I'm not going to run the whole suite. I'm just going to run this one test. And if we go look at our console, if you notice, test 1 has been excluded. So it's now taken out of the loop without us having to actually go comment out or do anything else to our code. However, that can get a little tedious. So there's some other things we can do. For instance, we can create what are called group tests. Group test is a new innovation or innovative feature in TestNG, which doesn't exist in JUnit framework at all. It permits you to dispatch methods into proper portions and perform sophisticated groupings of test methods. Not only can you declare those methods that belong to groups, but you can also specify groups that contain other groups. Then TestNG can be invoked and asked to include a certain set of groups or regular expressions while excluding another set. Group tests provide maximum flexibility in how you partition your tests and doesn't require you to recompile anything if you want to run 2 different sets of tests back to back. Groups are specified in your TestNG XML files using the groups tag. It can be found either under the test or suite tag. Group testing and suite tags apply to all test tags underneath. All right, so let's go into our test XML file and let's add a grouping. Let me go copy the code I've already typed out. This one will apply to just test 1. So I want to include BP, which is our data provider, and exclude our test 1. So before we run that though, let's re-enable test 1. So we have test 1, test 2, and BP. BP will run test 3. We'll go back to our test suite. And this is just in test 1. Test 2 should still run all the tests that we specified. We've made no changes there. All right, so we should see BP. Yep. Oh, that's test 2. So test 2, we have BP only. So because we didn't include and we didn't exclude, we only receive the data output for test 3. If we actually just did exclude test 1 without the include, we get test 2 and test 3. So in a way, you can get away with using exclude or include, but if you essentially don't exclude and you only do one include, it's only going to include that test. So really how I was doing it for this example really doesn't make too much sense because we have multiple tests in the same test suite. However, if we move this up a level and also now do the exclude, you see we've only got test 1. So it does make a little more sense when you're dealing with groups. You can include multiple or you can exclude multiple. Really, include, exclude, you probably want to do it one or the other, not both together. Now, the other thing you can do is you can actually define all. So you could actually specify a definition of groups. So we can create what's called a definition. So we can do a define and set all, and then we can tell to run test 1, test 2, and DP. And then in run, you can say include or exclude all. In this case, we will do include all. So the definition has to be defined inside of the test, but you could define your group, you could set the definition outside, and then it could be passed in for each of these. If we look, that actually ran all the tests. So if we go back up here again, and take this guy here. So you can set the definition up here and then pass it down. Or you could do this. So you get the gist. So we can set up definitions, we can include, we can exclude. Also, by setting up this definition here, you can actually create a group of groups. And then we can also include and exclude within our group of groups. Yep, test case 1. So let me stop here and jump back over. Does anyone have any questions?
So, Michael, so is this what you run at your job to pretty much verify like the system is working fine, like a regression and smoke?
Yes. I actually have a large collection of these. I probably have about 100 to 150 test suites or test cases, but I have roughly, you figure I have to run against 50 states, so that's 50 test cases, plus however many agencies are in those test cases. So I'm running probably roughly 20,000 test cases, but those test cases are essentially run off of data sets, but there's only essentially about 150 test suites or 150 test cases included in probably about 500 test suites.
Oh, that's huge.
Yeah, but see, I manage all that from the XML file. So that's what's the beauty of it. So I don't have to actually constantly keep going in and manipulating the test to go define my test cases, and then I submit the data to the test cases and let the test cases run the test, essentially how the data should be manipulated. We'll get into that more in the next one, possibly even the one after that, which I'll use to kind of go through my framework and where I'm at with my test software that I'm working on.
Okay. Cool, man. It's big, man.
Yeah, it's a lot of this, and the reason I really like the TestNG is one of the things that you will notice, so the code back up, is how these annotations work. So because you can do before test, before class, before suite even, you can now actually pass things or define the setup of your framework or your test suite for all your tests. Whereas with JUnit, the only way to really do that is through creating static methods or static classes that you have to pass back and forth through everything. And it becomes, you have to do a lot of compile time and recompiling and manipulating of the actual test code. Where this, it's all just XML files. It's just all configuration. You don't have to actually get into any actual classes or any code to actually build, define, and run your test cases. So your test suites are all essentially property files, which is what's really cool because it's all XML, and you basically can overextend if you wanted to and get really elaborate with it, but you don't have to. The luxury of this is you can actually define a couple test suites with some test cases in them. You can create some groupings for them, how you want to run them, and then you can pass in your data sets to essentially run the test case.
Okay.
Any more questions? Hearing none. So let's recap. Today we went over TestNG. So TestNG is not an extension of JUnit. It's its own testing framework that extends what JUnit was trying to do and actually gave us a whole slew of tools for our testing toolbox that we can now go out and actually build beyond the typical unit test. We can actually do the functional testing. We can do the end-to-end testing. We can get into the integration testing. A lot of this is through configurations and annotations, so we don't actually have to keep going out and recompiling our actual test classes. And finally, we walked through how to start building our TestNG files and setting up our framework with Eclipse. We looked at how to use the different annotations and the order, procedural order that they're actually executed. And we looked at how you could actually pass data using the data provider class, actually pass your objects to your actual test cases.
Thank you. We know your time is important, and if you would like to discuss any additional questions or comments you have, you can check us out on info@developernerd.com. You can check us out on developernerd.com/contact us. We're on Twitter @developernerd, and we're also on facebook.com @developernerd. Our goal is making every developer better. So please check us out, ask us questions, and check out some of our other videos.